Hey guys, welcome to Algos Explained. My name is David Kim, and today we're going to go over an algorithm called QuickSort. Just FYI, this video is going to go over the concepts of QuickSort, and in my next video, I will have the algorithm that I've written out to solve for QuickSort. So if you already know the whole how QuickSort works, just go ahead and go to the next video. I'll have a card up here, and if not, just welcome to QuickSort. And I do have my windows open today because it's kind of hot. And so if you hear a lot of background noise, I apologize for that. Shouldn't be too bad though. So QuickSort is a great sorting algorithm for sorting anything. That was loud. For the most part, when we're talking about sorting in terms of algorithms for like interviews and stuff, we want you to sort an array of numbers for starters. Of course, you can sort other things like words or whatnot, but let's go ahead and start with numbers. 4, 10, 7. Okay, and so what the main concepts behind QuickSort is that one, you have a pivot point, and so let's write that down. Pivot. You have a pivot and you swap. And so the idea behind QuickSort is what you would do is you would pick a number, pick a pivot point. Say we pick 10 as our pivot point, and what we will do is we'll have two pointers that will go from the left and the right. So say this is a left pointer and this is a right pointer. We'll go around and say, okay, if let's not pick 10 for our first example, let's pick 4. So if that's our pivot point or pivot number, we're gonna look at all the numbers to our left and say, does this need to be on the right side? And in terms of right side, that means, is it greater than 4? And if it's not, then we keep on moving until we find one that is. So left one, is it greater than 4? No, it's on the right side already. So we move on. 5, yes, this should be on that side. Once we have it all sorted, where do we want that? We want that to be on the other side. So we found one that shouldn't be on the left. We'll stop there. The right, does this belong on the right? The 2, no, it doesn't. And so pretty much what happens is we swap those. The 2 goes here, the 5 goes here, and we'll move the pivot points. And the concept behind that is we will continue doing that, and we will soon find a point where these points will cross. And when the points cross, that is kind of our partition section. And the idea behind QuickSort, it being a recursive algorithm, is that we'll get to a point where we'll split the array that we were originally working with, and now do QuickSort on this side and QuickSort on this side. And so that is just like super high level. This is what QuickSort is going to be. I really think that QuickSort is a lot better when explained with the algorithm, but just for reiteration purposes, I'm going to give you guys a fake kind of QuickSort that I have come up with, where the idea of it it'll make it a little easier to understand if swapping things it didn't make sense right now. And so if it didn't make sense, let's think of it as having a less array and a more array. And think of it as like this. Say you have a point that you randomly picked, and you picked out 4. And so how about instead of dealing with the left pointers and the right pointers, how about just removing the 4 from the array? And so we'll have 1, 2, 10, 7, 8, and 5. And now iterating through this array and kind of deciding, okay, where does it belong in the less and more? And we're not sorting it as we drop it into here. So we just go one by one. The 1 goes less than the 4, 2 is also less, so let's do that. 10 is more, the 7 is more, 8 and 5 are more. And think about it like this. So now you have a less and a more array, and pretty much what you want to do is you want to do QuickSort on these guys. So you want to do QuickSort on these guys. And so that's pretty much the idea behind what we did. Instead of creating new arrays though, what QuickSort did was we swapped them in place and we created a partition point where we can now run the function with parameters that will limit us to kind of just being in that area. There are definitely, if you look around the internet, there are definitely a lot of different ways to do QuickSort, and not too much, but I have seen a couple, and sometimes they say remove that to the other side. I'm pretty sure it all works, but the way that I found it most easy is to keep it there. And even if that needs to be swapped at a certain point, that's okay too, as long as you partition the arrays the right way. And by partition, I mean, or by partition, why that's important is because that is where you're going to start cutting things off and dividing up the work, like kind of right here, where if we didn't get this part right, if we didn't get the less ones right, and the more less than the 4, more than the 4, if we didn't get these arrays right, how could we do a quicksort on here and trust that at the end when we bring everything together, it'll be a sorted array? We can't. And so the partition point is the most important for quicksort. Picking a pivot, it's not important at all. All you need to do is pick a random number. And there are also different strategies for picking a pivot point. And of course, feel free to search that. The method I'm going to use is just picking a random number. That helps kind of randomize things and guarantee decently good time complexity. And so I believe that's kind of it for the explanation of quicksort. If I think of something else, maybe I'll add it to the video later, but let's go ahead and get right to the algorithm. I'm going to have it all written out and we're going to walk through it together. See you in the next one.